Good day, everyone. I'm very glad and happy to present this work in the second edition of the International Online Conference on Nanoscience and Nanotechnology. I am Mohammed Achehboune from the Faculty of Science, University Sir Mohammed bin Abdullah, Fez, Morocco. I am here today to present the work entitled Holmium Coated Zinc Oxide Nanostructures, Synthesis and Optoelectronic Properties. My presentation is divided into four parts. After a short introduction, I will present some of the experimental details. Then I will move on to the results. We will discuss the results obtained by scanning electron microscopy and X-ray diffraction and the UV visible spectroscopy. And then we will finish the presentation by a short conclusion. As you know, the zinc oxide nanostructures have attracted much attention over the last decades due to their potential use in electronic and optoelectronic application. Zinc oxide has a wide band gap, about 337 electron volt, and large binding energy. It's easy synthesis under different morphologies such as quantum dot, nanoroots, nanowires, nanobeads, and nanoflowers, using various methods of preparation, including, for example, hydrothermal method that is considered as an easy and simple method for obtaining nanostructures in a specific shape and size. The optoelectronic properties of semiconducting materials can be modified by coating process. So the coating of zinc oxide nanostructures with the rare earth may offers a powerful way to improve many interesting properties. Firstly, because rare earths are highly reactive and tend to form oxides very easily. Also, they act as good luminescence centers due to their narrow and intense emission lines originated from the Fourier intra-shell transition. In this study, holmium has chosen because it's a promising element that exhibits fluorescence in the visible and near infrared region. So the fundamental aim of this study was focused on the investigations of the effect of holmium on the structural and optical absorption properties of zinc oxide. For the preparation of our simples, zinc nitrate was used as precursor, so 0.1 mole of zinc nitrate was prepared using deionized water. The mixture was heated at 19 degrees Celsius in an oven for 24 hours, and the precipitate was formed, and after that the solution was washed many times by ethanol and deposited on substrates and dried at 19 degrees for an hour. Finally, the surface of zinc oxide was coated with holmium using the drop coating deposition technique. For the results of our samples, this figure shows typical scaling electron microscopy of zinc oxide, as clearly shown in the figure. Pure zinc oxide were relatively ground vertically and having hexagonal shape. The coated material was ground with different sizes and diameters. Nanorods have been thickly coated with holmium with higher defect density on the surface of zinc oxide. The crystallinity and structural properties of pure and coated zinc oxide were performed using X-ray diffraction. As can be seen from the spectra, the analysis reveals the presence of hexagonal wall-style structure. The ground for pure zinc oxide was in the three principal directions: 100, 002, and 101. For the coated material, intense peaks corresponding to holmium have been imaged, with the disappearance of 101 and 100 peaks of zinc oxide, which means that holmium have an effect on the crystallinity of zinc oxide. The optical absorption properties of holmium-coated zinc oxide was explored by UV visible spectrometer in the wavelength range from 218 to 1800 nanometer. The simple have an excellent absorption in the UV ultraviolet. Exhibits four absorption bands located respectively around 223 and 258 and 314 and 382 nanometers. The first three bands are assigned to the 44F transition of holmium as indicated in the schematic diagram. The band located at 382 nanometer is attributed to the PSRP transition of holmium from the valence band to the conduction band. So, in conclusion, zinc oxide nanorods have been synthesized via hydrothermal method and their surface were coated with holmium using the drop coating technique. Nanorods have hexagonal wall-side structures and ground with different sizes and diameter. The optical investigation revealed that holmium-coated zinc oxide have an excellent absorption uh, in their ultraviolet region. So this study was focused on the effects of holmium coating on structural and absorption properties of ZNO. So it's the end of the presentation. If there are any questions you'd like to ask, please email me. Thank you very much for your attention.